All right, new day and another Alienware that needs to be repaired, and this time we have one that's been to a repair shop because it wasn't charging the battery, but now the laptop's completely dead. The customer said that the repair shop tried to repair the motherboard and I guess made it worse. So I haven't taken a look at this yet. Let's take a look together and see if we can get this figured out. So first thing we'll do is see if it turns on and doesn't do anything. Let's plug in the power. And we are pulling 0, 0, 0, 0. Now that is a very bad sign whenever we don't pull any current when we plug it in. So let's go ahead and pop the bottom off and take a look inside. It's coming apart already. There's no screws in the bottom here. Okay, well that was easy. The bottom's off. Not a screw in sight, and nothing's plugged in. And that would make sense why there's no power. DC jack's not plugged in, battery's not plugged in. Looks like these Tron lights aren't plugged in. Is this even attached right here? Oh, the back cover's not even attached. So this thing came in with no screws, apparently. Screwing it together, I see an issue already. Behold, do you see it? Now, I don't know what I'm looking at exactly, but let's get under the microscope so we can take a closer look. Okay, what are we looking at? Is this a spill or is this a fix? Is that flux? What is this? Just flopping around right here. What is all this stuff here? Is that Coca-Cola? What is all this stuff? Is this solder? That's soldered to that one, that's soldered to that one, that's soldered to that one. What's this? What's this? What's this? What's this? Okay, so the customer's note said that it originally was just a charging issue, but the laptop would come on. And then they sent it to the repair shop and they said that they suspect the repair shop is a dubious repair shop. And I guess the repair shop made it worse and then tried to make it better by doing this stuff. I don't know. So let's just start by cleaning up all this. I have no idea, and maybe measure in this area. Let's measure if we have a short over here. I don't even want to plug in the DC jack. I know people want me to plug it in right now. I don't want to plug it in. So let's measure, see if we have a short in this area. So we're in continuity mode. Let's just measure across here. There's no short though, so that's good. Why is there so much solder balls over here? I guess they didn't have a hot air station. But I mean, this looks totally like a spill, but maybe that's flux or rosin or something like that. No short here, no short here. I mean, we got a short here. Well, that's strange. Why do we have a low measurement there, but not on any of those? What is these? I don't even think these are the right capacitors that go here. I think they're just kind of picking random capacitors. We have a lot of work to do, and I don't know why I always end up having to fix other people's mistakes, but I guess I'm letting it happen. I know a lot of repair shops would just turn this away because it is a lot more work, but it's so much fun, isn't it? So let me clean this up just a little bit. Just want to see what we're looking at here. It seems like look, that one piece just fell off. Here we go. Do you need this? It just fell right off the board just from toothbrushing. That's how you can tell quality. I don't see why they didn't clean up any of this stuff. Is that generally how you do it? Is you just put a bunch of junk on there, do some crazy soldering, and then leave it that way? This is the craziest rosin or flux I've ever seen. I mean, it really looks like just Coca-Cola or something, but it's not sticky, but it's everywhere. Maybe I should heat it up. Let me get the hot air out. Let me just try heating this up, see what it does. Maybe a little bit heats up. If it's rosin, it would just melt. If it's flux, it would just melt. I don't know. Somebody, you tell me what it is. I don't know what it is. Because you see, I mean, I'm at 450 degrees. There we go. Now we're starting to get some sort of melting going on, but this is really hot. You know, it smells interesting too. You know what? I don't have my air on. Let me put my air on. I think I might be smelling some poison. All right, now it's hot. Let's see if we can clean it better. Now this is 99% alcohol I'm using here, isopropyl, and it's not coming off. Maybe that's why they couldn't clean it. I think I should pull this whole board out. I should remove all of these chips. I mean, I don't really know what's going on over here. Do we just have like a blown chip and then does this screw even come out? Or is this a spill? Was it a spill they're trying to fix? All right, here's what I'm gonna do. All right, this is what I'm gonna do. This is looking pretty crazy. I wanna pull this board out because I wanna look around the board in other places. We may have some other blown components. I don't wanna get too deep into a rabbit hole, but we're already starting to go. I want to see if there's any other damage anywhere else, so let me get this board pulled out real quick and I'll be right back. All right, and the motherboard is out. So now we can actually take a quick look around the board. I want to look for any liquid damage because it did look like there might have been some liquid damage on here, but if we look down here, I would suspect that I would see some liquid damage. Well, on that little screw hole, that's the screw hole that went through and attached to where they were soldering with, maybe it's the rosin residue. So I don't think that's any liquid damage signs. I'm just gonna look around here real quick. So I don't see any liquid damage. All right, so now we have the board out. So here's our beautiful handiwork. And let's just look around this edge here. That connector's a little busted. Nice. Let's see, there's our BIOS chip right there. There's the EC chip. That's where the MCU or the keyboard plugs in. Battery plugs in there. That's where the DC jack plugs in. Okay, so I don't see anything else that's crazy noticeable right there. So I don't know exactly what happened over here. So I'm gonna ignore that for right now. Let's just keep looking around. So I'm gonna flip the board over and take a look. So here's our 3 volt and our 5 volt power rails. That's what controls the lights on the keyboard. Got a little bit of thermal paste here. Now, why is that out? Does that mean that they've had the heat sink off? Should I investigate that for liquid metal leaking? Yeah, there's some more thermal paste right here. This thing does have liquid metal. It does have a tendency of leaking on this model. Now, I don't know if they've pulled that off or not, but I'm assuming they would have if they're trying to fix this board. Where's our power management chip? I want to see. All right, so here's our power management chip. It's the 9241H. And so that's what controls these input MOSFETs here and also controls the charging of the battery. And so if it was having a charging issue, most likely that's the chip that's bad, usually. Or we have some other issue, but I don't see anything burnt around here. You would see a blown hole in one of these resistors or something like that, or that chip could be bad. All right, let's clean this area up. I don't know what all this stuff is. Maybe I can put my own flux on here and try to reflow it. I mean, it really looks like liquid damage, maybe. I don't know, someone will have a good idea of what it is because it doesn't really melt when I heat it up. Now let me grab a donor board so I can show you what it's supposed to look like in this area. All right, here you go. Here's our donor board, and we can see that this area is nice and organized, nice and pretty. So there's supposed to be 2 here. This only has 1 right here, but we should have 1 there. We're missing a resistor there, and the pad's gone. Looks like 3 in a row. They were trying to replace those. We have that there. This one only has 1. See, this one's missing a couple here too, but they were ripped off. This is a donor board, so I've already stolen parts or some of the stuff got knocked off. But all right, so we're gonna be able to replace any of these pieces here, and I may just pull all this off and then we can just move it all over. It looks like another, let's see, 2 capacitors here, resistor, capacitor. It's a horror show. I don't know if we're gonna be able to fix this. I really do not know. Let's look over here. Some other stuff going on. We got that chip there with these, that stuff. Hopefully it's just isolated to having a bunch of crazy capacitors kind of soldered in any orientation they liked. So let's just heat this up. Let's pull these things off. I'm just gonna pull off most of this stuff here, or at least all this for sure. Give you a little bit closer look at it. Is that what rosin looks like? I don't use straight rosin. All right, let's see if we can melt some of this. I'm gonna put my air on. I'm gonna add some flux on top of this while I'm heating it. See if I can get some of this stuff loosened up. Okay, let me just take all this stuff off of here. Okay, I think I know what they were doing. I'll tell you in mere moments. This one, I'm gonna pull these off too. There's a bunch of solder right there. I need to fix that, so I'm gonna get these guys out of their way. Yeah, I'm just gonna take this off too. Yeah, we'll replace that too. Okay. Replace that too. All right, let me see if I can wick up some of that. And then we can look at, see what they were actually doing. I think I have an idea what they were doing. I'll tell you in a second, but. Trying to get it all cleaned up so we can have really good visualization. So that's about the best I can clean it. So here's what I'm guessing happened. We had an explosion in this area right here, I'm thinking. Probably a capacitor that blew up. Now this is all supposed to be one pad here. That's another whole pad there. We just put 3 capacitors across here. And then on this other side, let's see, there's 2 and 3. And so this setup is going to be these, wait, which way does it go? Oh, these capacitors go here in this direction. And then we have a resistor that comes here, which that pad's gone. Does it connect right there? I can't tell. It connects over here at least, so we may have to put another trace here. Or if this is the same pad, then we can just attach it that way. And then a capacitor goes there. So we got a capacitor and resistor. But I'm thinking we had an explosion and they were just trying to rebuild this, so they were doing some weird like S-curve, whatever. I don't really understand why they did that, but maybe it's just because they were using a soldering iron and no hot air station. And I'm just amazed that the heat doesn't make it move. The flux doesn't make it move. All right, so let's compare the boards again. 2 capacitors go here, capacitor here, resistor here. I need to figure out if those are attached right there because then we can just hook it across there. 3 capacitors there, 2 capacitors here, resistor, capacitor, and that should clean that up. Over here we measured a short, right, or a 5 ohm short. Let me measure that again. So we have, no, it's a 0 ohm short. What about this? So there's no short over here. So why do we have a 0 ohm short on this area right here? I don't know. So let's figure that out next. See if we can resolve that short. I was assuming most of those would be all attached together. Surprised that none of these other ones are measuring short. Okay, we got a short there, short there, short there. Oh, we do have a short. Okay, cool. Cool, much better. Short there. All right, so that's exactly what I wanted to see. I want to see a short all the way across all of that, and then we can figure out which one's shorted. Now we could just have a cracked capacitor in this area. So let's get the thermal camera out. We'll do some voltage injection. All right, so since the resistance is close to 0, we can go down to like 0.4, something really low. And if we inject the voltage right in this area where we know it's just shorted, then we can see it on the thermal camera, but I don't know which side's ground and which not. So I'm gonna measure here to ground. That's 0.26, this side, 0.19. So this side's gonna be ground, so this is gonna be the positive voltage. So that's where we're gonna inject. We're just inject right there. We're getting about an amp going in. Do we see anything hot in this area? I'm gonna go up just a little bit. We want about 2 or 3 amps going through there. And I don't see anything in this area, except for where I'm injecting the voltage. So I'm going to move down just a little bit and inject in a different area so I'm not getting a false rating. All right, so the short is not in this area. So let's do a higher up overhead so we can kind of look all over the whole board and see if we can see it heating up anywhere. There's a higher overhead shot, and then I'm just going to inject right there in the same spot. This could be the CPU for all we know. Okay, nothing. So let's flip it over. We're going to have to pull the heatsink off, and we will investigate to see if we have a short on the board under the heatsink. The heatsink covers most of this side, so there's not much we can see. But I don't want to fix all that damage until I can actually see that the short is gone. The board should even try to turn on without that stuff there. Now, it's not going to get all the signals, so it probably won't power the CPU on, things like that, but it should charge the battery. We should get a main power rail. We'll probably get a 3.3 and a 5 volt power rail come up. So we got to work in stages, and we don't want to do too much work if this thing is a total loss anyway. All right, and the motherboard is off, and it looks like they did clean all the liquid metal off of here, and it actually looks pretty clean. Not too bad. Look, these are all the chips I've pulled off. Big pile of chips. Isn't it crazy? Look at this. There's more of that corrosion stuff right here on this USB-C connector. That's some of my flux right there, but all right. So I'm just going to look for some liquid metal drips or anything like that around here. I mean, why do we have so much like heatsink compound stuff around here? Oh, that has liquid metal mixed in it. Do you see that? This is more element 31. These people. So this stuff right here looks like it's only heatsink compound. Look, if I wiggle it and move it, there's liquid metal in it. This has element 31, has liquid metal mixed in with the compound. So let me go back over here. Remember that blob we found over here? And we're like, what is this stuff? Does this stuff have liquid metal in it? If I wiggle it around, and look at that, liquid metal's coming out. Liquid metal's coming out of that. Liquid metal's coming out of that. Well, what about this one? Yep, look at that. I'm bunching up the liquid metal. Are you seeing what I'm seeing, people? Look at this. That's liquid metal. What about this little blob right here? Is that just regular thermal paste? If I start smacking it around, moving it, liquid metal's coming out of it. See that? Okay, so what about all this? Liquid metal. So I'm gonna say that this board is really messed up. There is a high likelihood, like, I don't know, 90% chance or higher that this board is just complete trash at this point, but the only way we can proceed is to do a deep cleaning of it. And if we do a deep cleaning, scrubbing, trying to get under the chips and then put it through the ultrasonic cleaner, maybe there's a chance that we could save this board. It's a lot of work. All right, let me peel this off. Let's take a look. I hope you guys appreciate what I'm doing for you. This is the dam, okay? This is what prevents the liquid metal from leaking. This only works if you keep the stuff in here and then you don't wipe it all over the board. So this is useless. You don't even need that on there if you took the liquid metal off. Now, if you smeared it all over the board, then it's also useless too. This is all liquid metal right there. This is the flakes from the bottom of the tape. That's okay. This is stupid. Bro. Okay, let me pull this guard off too. I'm gonna heat this one up. Makes it come off a little bit easier. Now, I'm not surprised that there was an explosion on the other side of the board. Now, I don't know what came first, which the chicken or the egg, but I don't know. These stories aren't lining up, so I have no idea. Charging issue, and then the board didn't work, but this is, their liquid metal was taken off at some point and spilt everywhere. And I can't even say this is like an honest mistake. I mean, look at this. Okay, so is this what you call an honest mistake? So that's all liquid. This looks like regular thermal paste, right? But see how I'm wiggling it and it becomes shiny and liquid metal? What about this big blob right here? Do you think that that's just regular stuff? Let's see. If I poke it. Now that one actually doesn't have liquid metal coming out of it. That actually seems okay. But it's all this stuff that's kind of just, it almost looks like sand from a river or the ocean. But yeah, if I move it, it starts having liquid metal come out. Oh, we found a hair. Get the forensics team out. I think we need to figure out who did this. Is anybody in forensics? I could send this off to you. All right, so this is gonna need like an alcohol bath, a lot of cleaning. We're gonna need to make sure we don't have anything going underneath any of these chips, the VRAM, the CPU, the GPU. We're gonna get the ultrasonic cleaner going. Look at this. Do you see that? Like how close all this liquid metal is from going underneath there? So I'm surprised it's not already under there. And it looks like it was liquidy, so it almost looks like they had it wet at some point already. So here's underneath one of the VRAM chips. It's definitely stuff under there. All right, so here's what I'm gonna do. I'm gonna do a quick scrubbing of it. I'm gonna put it through the ultrasonic cleaner. I'm gonna scrub it some more. I'll probably put it through the ultrasonic again, and then we'll see what it looks like. All right, I'm just gonna scrub this just a little bit, but I'm kind of worried that we have a short somewhere that's not in a good location, right? That we can't access as underneath some sort of chip. Now, ultrasonic cleaner is definitely gonna help with that, but we still have to be a little bit cautious. Now, I'm assuming this is probably what they did, is just kind of doused it with alcohol and scrubbed it. And that's why it kind of looked like it was, I don't know, almost sandy, rubbed everywhere. Now, I'm gonna be wiping this off and we're gonna be drenching it and dousing it, and I've done this plenty of times. I know there's liquid metal everywhere, but let's inject some voltage. I wanna see where the short is because we figured out that it looked like it was on the main power rail, I think. Actually, let me measure. But we had a short on a power rail, right? And when we injected voltage with the heatsink on, we couldn't tell what was happening. But an easy way to find a main power rail would be something that feeds another power rail, right? So we measure right here, definitely have a short going in there. What about over here? No short there. So this is the 3 volt and 5 volt, and then we have the main power rail supplying voltage there, but we do have a short on that. So I can inject voltage right there, and we still have a voltage injection tool set up, so we'll just use that. Going thermal, here we go. And it's definitely not pulling as much current as before. Maybe it's because it's going through some liquid metal. And you see how nothing's really heating up? I see some reflections and stuff. Oh no, I see the GPU's heating up. See that GPU's heating up? So is this a case that we have a shorted GPU in the first place that started this whole thing? It started them messing with everything else? The fact that we are getting a heated up GPU means that one of these MOSFETs are shorted. Now, I don't see any damage over here. All right, the main power rail supplies voltage to this capacitor here, and it goes through these MOSFETs that will produce a power rail that powers the GPU. So one of these most likely are shorted. Now, I don't know which ones are connected together and which ones aren't. So those are all connected together. Looks like all of those are connected together. All right, so all of these are connected together. So I guess it doesn't really matter which one I inject on. So we're gonna inject voltage, but we're gonna use the bypass method. So instead of going through the GPU, we're just gonna go straight to the negative part of my injection tool here. So I'm just gonna clip it onto my probe here like that. And we can turn down this voltage. We don't need that much now. All right, let's go back to the thermal. And now I'll inject on the input right here. And it looks like it's right in this area right here. Right there. Let me move it over here. Let's see if we can see that better. You see that heating up right there. I'm gonna up the voltage just a little bit so we can get it a little brighter. Is it a capacitor or is it that MOSFET? It does look like we have a little bit of debris on there. Right here, this one. Looks like it might be on the edge of that, so I'm gonna go ahead and mark this as bad. So we'll pull that guy off right now. I'm trying to do a little bit of work now just to kind of rule out stuff, because if we're going to go in through and cleaning and scrubbing and ultrasonic cleaning and doing all this stuff, we need to make sure the board even will function, right? What is this stuff here? I don't know. This is really bad stuff here. All right, I'm going to pull this off. All right, this is a thick board, so it takes a little bit of time to heat up. So I'm going to kind of preheat the area a little bit. We're going to add a little bit of flux once we have it warm. Now this is a tantalum capacitor. These can get damaged from heat, so we're going to be a little bit careful because we don't want to sit there and blow a lot of heat on it. So I'm going to kind of blow in this area. Now this could just be a liquid metal drop that's in here that's causing this. What is that? Is that solder or liquid metal? Okay, we got that off. So here it is. Okay, let's measure to see if the short is gone now. And the short is gone. Okay, so we'll come back over here where we were measuring earlier, which is the input to the 3 volt and the 5 volt power rails. No short there. All right, so that short is resolved. Now we'll flip it over and we'll come over to our crazy chaos. Remember we had measured a short across these capacitors like this, and that short is gone now. I gotta wait for these capacitors to fill up and it's good, all right? Will it turn on? Probably, but will it post? I don't know. And so we still have to replace that, replace all that junk there on the back. But I think I'm just gonna ultrasonic clean all this stuff first and then replace it, because I wanna get all this stuff off of here that's all over the board. The amount of debris that's on here is crazy. And you can't just throw it in there. We're gonna have to kind of scrub it first. And maybe I'll give it an alcohol bath first and scrub it. But I don't want any more stuff going under the CPU, so I'm kind of back and forth on this. All right, I don't know which approach you'll take, but here's what I'm gonna do. I'm gonna clean this stuff off, the thermal paste and stuff like that. I'm going to just go ahead and do the ultrasonic clean. We're gonna do an alcohol bath, then we'll take it back out. We'll do a scrub, take a look at it more, see if we can clean anything else up. I'm gonna throw it back in the ultrasonic cleaner for a second time, do another alcohol bath, and then we'll finish up by, we'll probably check to see if the thing powers on, and then I can replace this stuff, because these things aren't necessarily important to power it on. I just want to see if it actually will try to power on, and then we will see if it works. All right, and look at this mess. Look at this mess. These are all different chips that I've taken off. There's piles of them here. So I'm gonna clean up my whole area here afterwards too. All right, just a Q-tip and then some isopropyl alcohol to clean this off. Now they didn't go crazy on the thermal paste, so they applied it correctly. It's just that they made a mess of all the liquid metal. And I've seen this in the past because you just can't tell if liquid metal got everywhere because you don't have a microscope. If you had a microscope, it's a lot easier to see, but without a microscope, it's very hard to tell if you're getting stuff everywhere, especially like if you do what I'm doing right now, you're like wiping, I'm gonna wipe all this stuff off. Well, if it was liquid metal, you always want to, I usually don't use these at all because you're gonna have some that's over off to the side and it's gonna rub everywhere. It's almost like, you know, stepping in paint and you don't know you step in paint, you start walking around your house, you know, it gets everywhere. This stuff that I'm wiping off is non-conductive, so I don't have to worry about that. And maybe they thought the other stuff was non-conductive, I don't know. All right, so let me put this in the ultrasonic cleaner real quick. I'm gonna end up putting in this ultrasonic cleaner for about 2 minutes on each side, and then we'll pull it out and clean it. So I already have it preheated. So we'll set it in just like that. And then we'll put it on oscillating. All right, it's been 2 minutes. Now I'm gonna flip it around to the other side. Oh my gosh, there's all this stuff coming off of it. I could see it. So now I'm just gonna lean it the other way. But when I moved just now, all this stuff just came off of it. That's crazy. I've never seen that happen before. All right, another 2 minutes on this other side. All right, it's been 2 minutes. Let's pull it out. I'm gonna put it into my tub here. This is my alcohol tub that I use to clean it. So let me just see if I can wipe this off. So I'll leave that on so it's ready to go. Okay, so I have it in this rubber tub here. The idea with this is that I can actually just dump stuff right down in here, and then I can collect it later if I need to. Now I'm gonna use this stuff I don't generally use. This is a spray version of 99% alcohol. It has a little bit of pressure on it. I usually just dump it on here, but aerosol version seems like it might be the trick. And the reason why you have to use alcohol is you need to displace all the water because you don't want to leave any water inside of here. And so we'll use the toothbrush here to scrub it a little bit. So we don't want to leave any water underneath any of the chips or anything like that. And so what's inside the ultrasonic cleaner is actually just distilled water and a ultrasonic cleaning fluid, Bronson fluid. I use the industrial strength, so you don't need as much, but there's an electronic cleaner too. Okay, so that looks pretty good. Now I'm just gonna blow it off, and that should dry it, and it'll make sure that we get everything out from underneath each chip. I'm just gonna put some extra alcohol under these chips here. Okay, let me go blow dry it. All right, that's pretty good. I just have this little zip tie in here, if you're wondering, that helps me grab it. Now the board does look actually pretty good at this point. So do we need a second dip? I don't know. So let's take a look around the board real quick. So here's around the CPU. Looks a lot cleaner, doesn't it? A lot cleaner. And we'll be able to see any blown chips too. Now over here, you remember we had liquid metal like right up against this MOSFET here, or against that one. That's not there anymore. That looks nice, nice, nice. Looks very good. And over here, what about over here? This looks good. There's the power management chip. Looks like a brand new board. Let's look at the back. And this area even got all cleaned up. Look at that. So the ultrasonic cleaner actually did clean up all that. So now we know exactly where we need to put our chips. We'll replace that. I don't know if we need to do those or not. I have no idea, but we'll replace all that stuff and fix some of those things. But it actually looks pretty good. So let's go around the board and just make sure we don't have any shorts. So I'm in continuity mode. I'm just gonna check all the power rails, make sure we don't have a short on the power rail output. It's a battery, it's the main power rail. This is gonna be RAM, a VRAM, so right around 40, 35, 40, that's fine. And then here's, that must be the actual DDR5 RAM, or DDR4. That's fine. That's fine. Let's check the chipset, see if our chipset's shorted. Chipset looks good. Okay, that's fine. Well, one last thing actually, I want to measure the CPU and GPU just to see what we have there. So GPU should be like 0.3, that's good. CPU should be what, 2 ohms? We're getting 35 ohms. Why are we getting 35 ohms? That seems like the wrong value, so I'm not sure why we're getting 35 ohms there. What I want to do is I'm going to power it on. I want to see what it does. So let me get a DC jack. Actually, before I turn it on, I did blow dry it, but I'm going to heat dry it too, just to make sure we don't have any extra water under any of these chips. Sometimes these things will keep some water under there. Okay, no liquid came out. All right, so here's the plan. I'm gonna plug this in, and we're just gonna monitor it under the thermal camera. We just wanna see what is gonna get hot and what's not hot. And now I have the board nice and warm, so we should be able to see a pretty good outline of the board. There we go. So that's because I preheated the board ahead of time. Now we're not gonna see any subtle differences in heat, but we're gonna be able to see something that does spike in heat. You ready? So I'm gonna plug it in 3, 2, 1. 0.01, 0.04, 0.02. Okay, 0.02 is where we want it to rest, and I'm okay if we went to 0.04 for a second. And I don't see anything getting hot. 0.02 shouldn't have anything get hot. Let's see if we can trigger it on. So here's our power button wires right here. It's gonna be these first two. We can also just trigger the switch right there. So that's what I'm gonna do actually. But I wanna be high enough up here so we can see it. All right, is it coming on? It's not coming on. Now it could be because we're missing a resistor or a chip on the back side of the board. But we do have resting voltages that I'm happy with, so that at least allows me to want to proceed. So I'm going to proceed with rebuilding some of this stuff. Now it probably won't come on with this chip not installed right here, so, and then some of these other items. And this was a resistor, and it looks like it goes to that via right there. Ooh, that's going to be a tough one. I was hoping that we're just going to connect it over here. Oh, wait, we are. Look at that. I think this connects here, and that connects there. Why didn't we just connect across there? Is that right? Here, let's measure that. Do you see what I'm looking at? I'm trying to figure out if I need to build a trace that goes here and these are independent, or if this connects to there and they go together. So we're going to have to measure that out. So I'll measure right here on that to here. They are not connected. Oh, I can see now. So this is connected through a via right here, so that's the trace there, and then this is its own via going here. So yeah, we're gonna have to have a wire or a trace that's put in right here to allow us to connect a resistor across there, and then this is a capacitor that goes across there. So that's gonna be a little bit more complex than I want to deal with, but you know, for stages of fixing this, we're getting there. So let's install this component and some of this stuff over here, and then I'll work on that. These capacitors we can live without for testing purposes. And that other MOSFET that's on the GPU, I can live without because the board will still come on. That's all we're trying to do. I don't want to put a new MOSFET on there if we don't need to, if the board's not even working. So I'm going to put that on there, and then we'll start building out all this stuff here. Now I'm definitely lucky that I have a donor board, because having to track down all these parts or having a schematic or board views would be a lot more complex. So we're going to take that off. These two capacitors right here. What else do we need? What about those things? Nope, those are not populated. What about these three? Those three are still there. So we're going to start with those three components. So it's these two caps and that BL01. But first we're going to have to put some solder on those pads. I got solder on all these pads now, so these are ready to go. Now these two are supposed to be touching together anyway, and then these two are the same pad also. This area is actually the same pad. I'm not really worried about that because I don't want to have to rebuild the solder mask or anything like that. That's ready to go. Let me go ahead and pull these chips off. Two capacitors and a BL01, which is kind of a power gate. All right, now we can get it installed. And tack that in place, tack these in place. All right, now that I have them tacked in place, we'll just add a little bit of flux, and that will help us seat them down properly. There we go, that one's good. See if I can pick up this little ball here. Perfect. All right, and this guy is a little crooked, but I'm okay with that. All right, let me clean that up. The next thing I think we need to do is this guy, because without him, I don't know if the board would turn on. Let me scrape away at this and see if I can connect a new pad there. Actually, I guess I can put solder everywhere over here. I don't want to flood the area, but we want to have enough solder. If you put too much, sometimes the chips don't lay down flat. So in the one spot that I wanted solder, there's not much there. I think that's good enough. Let's go down into it closer and see if we can get this connected. All right, so I need to clean this really well. Well, see, it's a mix because I need it to be clean so I can actually use solder mask to hold stuff in place, but then I need to have flux in order to have the solder flow. So let me think about this. Let me get a pad. Okay. So I'm going to put a little bit of solder mask down in there, and that will hold it in place, and then we'll try holding it there. And then once the solder mask cures, then we can solder it on. Okay, solder mask in place. There we go. That's how I want it. Let me cure that real quick. All right, so that now is in place and lines up right there where I can solder. I have to put a little bit of flux here. Perfect. So that is now soldered together. I can break this off. All right, so we have the new pad put in place. Now I just need to put some solder on it, and then we can install the resistor. I think we're okay with not doing all the capacitors right at that moment, but there we go. We'll just test to make sure we have continuity at least. So that's connected. Okay, so we can back out here. So that's the overhead view, what it looks like now. It's starting to look a little bit better. So I want to fix this crooked guy right there, and then we're gonna solder on all these other components. I'm gonna go ahead and just do them all. I was just gonna do a couple of them, but since we're already doing it, we'll just do them all. All right, I was getting this pad ready right here, and then this one fell off too. So let me get this removed, and then we can replace that one while we're at it. The whole bottom base is stuck on there still. Okay, so those are all ready now. All the pads are ready. Let's do it. I'm gonna start on this side, and I think I'm just gonna come in here, grab one of these, put it on, grab one, put it on. Sometimes it's kind of hard when you're doing piece by piece, but I'm just not even gonna try to focus in between. I'll just keep focused on the other board. And all these are gonna be the same value, so I don't have to worry about which one I'm taking and which one I'm not. So these actually go this way, so I need to go this way with it anyway. Like that. Goes there. Okay, so then these are going to be another set of 3. So I'll start with the furthest. And this one's blowing around over here. Okay, so we need 2 of these guys here. I'll be surprised if this board works. And there's our rebuild there, so I'm going to put the resistor on first. No. See, whenever I rebuild a trace, I'm very, very fragile with it, so then I end up not holding down the part that I'm installing well enough. I want to soldering it. There we go. Good. Okay. Now we can reflow everything. I think we got everything installed. I'm just going to reflow and make sure everything's sitting properly. These things are blowing around. I'm going to bring down my airspeed just a little bit. This stuff's moving around. I have a little bit too much solder on some of these pads. When you have too much solder, then you end up having a little bit of an issue. See how these want to stick together like this? Now it doesn't matter if these are all together because they're all in the same traces and pads. So I might just put them together like that. Perfect, okay. These 2 I'm gonna put together also. These guys are just dancing around themselves. I guess I'll put those guys together too. Okay, looks a lot better than it did. Go ahead and scrub this up, get it all cleaned again. Now, I don't know if we need to send it through the ultrasonic cleaner again, because it actually is looking pretty good. I'm going to put a before and after on the screen here, so you can see the difference between the two, but I think it's pretty nuts, right? The difference is pretty incredible. The only thing that doesn't look very good in this entire process or thing is going to be this set right here. Now I can put some solder mask around that. Maybe I'll do that. See if that will make it look better. Put a little bit of solder mask over this whole area. Now function-wise, it's going to be the same. It's going to work the same. We'll go ahead and mask that too. All right, let me cure that. Those 2 pads I don't care about. That's fine. Everywhere else we got fixed. But will it work? Doubt it. Well, all right, did you place your bets? Did you figure out if I was able to resurrect this catastrophic damage from a repair shop? I don't know. I mean, we still have this MOSFET we're going to replace afterwards, but I want to see the CPU come on. I want to see it look like it's going through a boot up process. That's what I want to see. If I can see that, then I'll go through the process of doing that. If it doesn't happen after this, then we're going to call it on this board because too much work has already been put into it and it's probably a lost cause. So we're going to get under the thermal camera again. We want to see it come on. We want to see it come to life. So keep an eye on the power meter. There we go. 0.02 is good. Let's use our tweezers to turn it on. And we're getting a CPU, come on. 0.05, and that's it. 0.04, and that's it. That's all we're getting. That's nothing. We should jump up to about an amp. We should go to an amp and a half. We should be moving around. So let's see what power rails are actually turning on. All right, so here's the 3 volt and the 5 volt. So I'm just gonna measure those. We have our 5 volt. We have our 3 volt. What else do we have? I doubt the chipset's coming on because we get 0.07 over here. Does it charge the battery? Here, let me see if we're getting voltage on our BIOS chip, like if it's gonna boot up the BIOS. We got voltage on our BIOS chip. Okay, interesting. And see, it draws me back in. When we have the 3 volt and the 5 volt power rails, we have the BIOS chip coming up. There's a possibility that we could have a firmware issue at this point. It could be an EC chip programming. It could be a corrupted BIOS. I doubt the corrupted BIOS is the case, but let me plug in the battery and see if it starts charging the battery. I mean, the odds are there's some other blown chip or resistor that we just don't know about somewhere else, and that's probably really what's going on. But I'm just gonna plug in the battery, and we want to see if we're getting any charge current. Battery's plugged in. Want to see it jump up to about 0.2. Okay, good. And it went back down. What the point? Okay, well, I got an amp and a half, 1.87 amps. So it is charging the battery. All right, so now let's see if it powers on. It's not powering on yet, right? Let's see if it powers on with the battery plugged in, because sometimes we have an issue with that. Let me check the thermal camera. You can see the EC chip is on. We can see the charge circuit's all warm over here, but I'm not seeing it pull any current like it's turning on. I'm going to try to trigger the power button again. Nope. Here, let me plug in the power button and see if we get an error light or something like that. So I have the power button plugged in. I'm going to press the power button. Nothing's happening. And we would see it get really hot behind here if the CPU or GPU was coming on. All right, let me unplug the battery again. Charger plugged back in. You see the EC chip is on right there. I pressed the power button just now. 0.03, 0.05. So 1 watt's being pulled. And we don't see anything. Nothing's getting hot enough in order to tell us that there's some sort of issue somewhere else. Okay, so I'm going to take it back out. We're going to do a little once over and see if we can find a blown something. There's already too much damage. So let's just check all these 4.7s, see if any of them are blown. So those are all fine. These are the ones we replaced. Fine. Okay, let's just check to see. Well, we're not going to have a short on the main power rail because we do have our 3 volt and 5 volt are coming up. This is going to be on the CPU. So now we have 5 ohms on the CPU. That's what we were supposed to have earlier. Is that just a scratch there? I bet there's going to be some ripped off component somewhere. That fuse is good. And are we measuring a short over here? Nope, capacitors are just filling up. See, sometimes it's tricky. Look at this connector. I can't believe they did that to this connector. See if this fuse is any good. Good. We probably have something still under the CPU. So ultrasonic cleaner one more time maybe. Might be an option. We can just try hitting it too. Flinging it. See if we can dislodge some stuff. Let me try that. Let me try that next. I don't know. There may be liquid metal underneath one of these chips. So by hitting it, we're using gravity and inertia to move that around. So now if I plug it in, let's see if it pulls a different amount of current. If it pulls a different amount of current, then we definitely have something under there. 0.05, 0.02, and then now we turn it on again. and exactly the same thing. So that didn't change anything. So I think it's a low likelihood that we do have something underneath one of the chips. So we have a higher likelihood that we have a blown chip somewhere, a blown resistor or something like that that we haven't seen. And I guess I'll program the BIOS just for fun. It'd be annoying if it was just the BIOS after we put all that work into it. And that's what always ends up happening. So I end up spending all this time because I do a lot of work and then it doesn't work. And then I'm like, well, the last thing I try could fix it, and then it makes all my work, you know, count and not be a waste of time. In general, I would probably just sell them a new board, but these are expensive, so. You know what, let's check that. You remember there was a bunch of liquid metal over here? That's right, so we could have a blown dual MOSFET there. Let's see. And we did see 0.7 over here. So 0.4K. So that's 166, so that's not showing shorted or anything like that. So that's a ground plane. This side's ground, that's not ground. Okay, perfect. So that would be ground, that's not. All right, so that looks fine. What should I do? You want me to put that on? That's not going to do anything. So tell me to do something different than that. Because I could take all of those off and this board will still turn on. This doesn't, it's this, that's the GPU. So the startup process is something else. But the fact that we have 3 volt, 5 volt, and then we have the BIOS chip coming on, I don't necessarily see the chipset coming on, right? The chipset's not coming on. The RAM power supply maybe not coming on. Yeah, I'm gonna try powering it on again under thermal camera. Let's just see what is coming on. Because the RAM should be coming on. Chipset is coming on. We have heat right here, right on the edge. So that's good. So we know the EC chip, the chipset, and the BIOS chip's all coming on. So either we have a corrupted BIOS or we don't, it's missing something else for it to continue. So let's see if we have our RAM power supply, which I think is this guy. We don't have that. All right, so what I'm trying to figure out is if we're not getting our RAM power supply to come on, then that could be an issue. And so what I like to do is I like to measure some of these resistors, make sure we have voltage on both sides, all the way around these chips. And some of them aren't supposed to have that, but that's what we'll address at the time, right? So some will just be a pull-up when there's nothing on there. Some will be pass-through chip, like a 0 ohm or something like that. So we have 3.4 on that side and we have nothing on that side. Now, does that mean that when it's not started yet, so I'm going to unplug it, plug it back in, do we have 3.4 passing through and then it's supposed to go to 3.4, or is that thing blown? So what is this measuring at? It doesn't look blown, by the way, but so that's 100K. It's measuring 100K, and we are measuring it in circuit, so it could be wrong, but that's how we start. Oh shoot, we're almost at 2 hours. Okay, so I'm going to keep going. So we're not getting any voltages there. This is the one that I think I want to measure anyway, so let's see. 5 volts on that side, 5 volts on that side, 5 volts, 5 volts. And this should be the 20 volts coming in, right? So 20 volts coming into this MOSFET, and then you should have 1.2 volts coming out here. So let me check this MOSFET and see if it's shorted or not. Um, 0 ohms. Let me put it in diode mode. Okay, are we measuring a short over here? 0.02 in diode mode, and then let me go to resistance. Resistance is 46 ohms, which is right. And where's the other MOSFET for this? Is there another one on the other side? Nope. We usually need another one. Where's the low side? That's a dual MOSFET. All right, I gotta look around and see what these power rails are. I think that is the RAM power supply, and I want to figure out if this chip is not turning on, if it's not supposed to be turning on right now. I don't know, so I'll be right back. Okay, I give up. I went ahead and sent it through the ultrasonic cleaner one more time. I don't know. This is probably a lost cause. I just really don't know if I should keep working on this or not. I have way more machines to work on. This is not like I need to fix this one, but I don't like not fixing things. I'm sure most of you guys agree that I should probably just give up myself. You know how it goes. I probably shouldn't even accept machines that somebody else has worked on, but kind of enjoy it, actually. Okay, so if this doesn't work, I'm gonna have to give up. It should work, right? It should work. I highly doubt it though. Again, we're gonna just dry off anything else. Pressing the power button now. 0.05. Same thing. Oh, okay. Tell you what, since this is giving all the signs of a BIOS issue, I will flash the BIOS, and that will be the last thing. This is what always ends up happening. Just one more thing. So last thing I'm gonna try is a BIOS, just because it is turning on the power rails and it's giving the symptoms of a corrupted BIOS. Let's do that. All right, so the BIOS chip we have here is a 25R256JV. And let me pull that BIOS up I already have made for this machine, and I'll flash it over real quick. Well, good news. I don't have a BIOS made for this, and I'll have to make one. So I will take my donor board and steal the BIOS off of it, and then create one. So let me rip the BIOS off of this donor board, and then I'll have to build one. But I'm going to spare you all those details because I've done that in other videos, and this video is already long enough. Okay, I built a new BIOS. I backed up their BIOS. I'm about to flash the BIOS on here now, the new BIOS. So let me go ahead and get that going. This will take a few minutes, so I'll be right back. All right, so that is programmed. Now, do I think this is gonna fix it? No, but the thing is that I have to do every single thing, or else, just for my sanity, to make sure that I'm not just like chincing out or skipping something, right? So it is experiencing the symptoms that I would see if I had a bad BIOS, okay? So if this board came inside this laptop and it was doing this exact thing, flash the BIOS, okay? So we do have it to that state. If this works, it works. If it doesn't, I'm done. And hopefully you agree. All right, plug in the power, 0.02 and 0.05 again. That's it. That's all she wrote, folks. So I'm calling it on this board. This board's gonna need to be replaced. There's nothing else that I want to do with this. They could send it to a third repair shop if they want to, but I'm not gonna mess with this. So we'll have to sell them a new board. I don't know which version of the board they have. These boards are gonna be around $500 to $1,000 depending upon what version they have. And but I'll have a discussion with them about that. And we did a lot of work to make it look good. It looks almost brand new. Look at this board. Look how pretty it looks. But it doesn't work, so who cares? So anyway, if you like the videos I'm making, make sure to subscribe. I'd love to know your thoughts on this one. Thanks for watching. I couldn't save this laptop.